Okay, so for today's lesson, we're going to talk about the chain rule. And specifically, because right now we only have worked with the the power rule in class, the chain rule as it applies to the power rule for power functions. So first of all, we need to talk a little bit, just a reminder, about composite functions. All right. So let's take a look over here. And a composite function is just a function made up of two other functions where you have one function inside another. All right, so we took a look at a problem in class yesterday that I had to work out with the quotient rule because I said we couldn't do it yet any other way. The whole idea here is you've got a general power function. So let's say we had something like h of x is, I don't know, x squared plus x plus 1 squared. Now, if I wanted to take the derivative of that, it wouldn't be too difficult for me to just multiply that out, get a polynomial, and then use the power rule to take the derivative of the polynomial. However, if instead of being raised to the second power, if that was being raised, let's say, to the 100th power. Now, could I multiply that out? Sure. Do I want to multiply that out? No, I do not. All right. And then there's also, cases where there's really nothing I can do to simplify a problem if that was under a square root sign. All right, something like that. Well, there's not a whole lot that I can do, right? Because that's a power of 1/2. So even if I wanted to, I couldn't multiply that out. So the way we're going to do this, the rule that we're going to use to do this is called the chain rule. And I'm going to, let's take a quick look at a little diagram here. I pulled this out of the book. All right, so we again have a composite function, right? And our composite function is h of x equals g of f of x. And this is just the, the standard pre-calc when you're first learning about composite functions diagram of how a composite function works. All right, so you start with your domain variable x. And the way the composite function is written is you first put x through f to get f of x. Now, to simplify the notation, we're going to call f of x u. So then the next step would be to take f of x, or u, and put it through g to get g of u, or g of f of x. All right, and this is just h. They're calling h y, right? So y is just h of x. So now if I wanted to take the derivative, let's say, of h of x, all right, I've got to think about that a little bit. And probably the easiest thing to do would be to kind of simplify the concept just a bit. All right, so let's just say, for the sake of argument, that f changes 3 times as fast as x. So if f changes 3 times as fast as x, that's giving you a rate of change for f. So that is f prime of x. And if it changes 3 times as fast, then f prime of x would be 3. And let's say, for example, that g of u, right, that g changes twice as fast as u. So that would mean g of u, g prime of u, twice as fast would be 2. All right, so I have a way of writing those rates of changes. Now, if I want the derivative of h, right, if I want h prime, then the notation I can use over here on the left would be dy dx would be h prime of x. So if I want dy dx, it would be helpful to have these written in terms of that same notation. So if f of x is u, then f prime of x is du dx. And if g of u is y, then g prime of u would be dy du. So if I want dy dx, right, dy dx, I can get that by taking du dx and multiplying it by dy du. Because what's going to happen when I do this multiplication, right? Well, the du's are going to cancel, and I'll have dy dx. Right? So I get the derivative of h by multiplying the derivative of f by the derivative of g. All right, so for this particular problem, right, what would that be? That would be 3 times 2, or 6. All right, so we're saying that h changes 6 times as much as x, 6 times as fast as x. Okay, so we can put this together into a formula for the general chain rule. Chain rule. All right, which is if I have h of x is g of f of x, then h prime of x is going to be f prime of x times g prime of f of x. All right, now since right now we really only have the power rule as our basic form of taking a derivative, I'm going to narrow this down to the form of the chain rule specific to power functions. And we call that the general power rule. So the general power rule is written this way again. So I'm going to take my h of x to be f of x, some function, to a power. Then h prime of x, the derivative of h of x, I apply the power rule, so that is n times f of x to the n minus 1, then I multiply that by the derivative of f of x. All right, so let's take a look at a couple of examples. All right, so we can start with let's see, which example do I want to start with? I guess I'll start with, well, let's start with one that we can't do any other way. All right, so let's just jump into this with a problem that there is only one way for me to do that. So let's take a square root. So let's call f of x the square root of x squared plus 1. All right, now before I can use this function, before I can take the derivative of this function, I need to have it written as a composite power function. Essentially, I always want to rid myself of any notation. So x squared plus 1 to the 1/2 power. All right, that's an algebra step there. So then to take the derivative, f prime of x, all right, I'm going to come over here. So we're going to first apply the power rule. All right, so I apply the power rule, I bring the power down, times x squared plus 1 to the power minus 1, so that's going to be minus 1/2. Then I say times the derivative, and I'll do this in 2 steps, the derivative of the inside, x squared plus 1. All right, so this ends up, being 1/2 x squared plus 1 to the minus 1/2. Then this derivative is The derivative of x squared is 2x. The derivative of 1 is 0. All right, now at this step, I'm done with the calculus. Right? I've got no more calculus to do. Anything else that I have to do is algebra. All right, so first of all, I notice here that I have a 2 and I have a 1/2, so those two are going to divide out. So what I'm left with then, because this is to the negative 1/2, it's going to go down in the denominator, so I know I'm going to have a fraction. The x is to a positive exponent, so x stays on top. X squared plus 1 to the 1/2 goes into the bottom, and that would make that the square root of x squared plus 1. All right, so that would be the derivative. Okay, now we can combine, right? There's places here where I can combine our different rules, because think about this now. We've got our basic rule, the power rule. We've got a product rule, a quotient rule, and now we've got the chain rule. So you saw some problems in the last homework set that combine product rule, quotient rule together into one problem. So now let's add in the idea of the chain rule. So if I have f of x is x squared times 2x plus 3 to the 5th. All right. At this point, you have to, again, fall back on your algebra knowledge, because you need to know what type of function you've got. Is it a power function? Is it a composite function? Is it a composite power function? Is it a product? Is it a quotient? What is the big picture here? All right, so when we look at this one, and sometimes it just helps to read it out loud, x squared times 2x plus 3 to the 5th. So that times right there, that multiplication tells me this is a product. All right, so I'm going to do what we've been doing, and I'm going to write down our product rule. All right, so uv prime is u v prime plus v u prime. Right, and I'll label here u and v. Now I'm going to write out the product rule, but I'm going to do it in steps like we did when we first learned the product rule. Right? So we do u, x squared, times the derivative of v. So the derivative of v is this for right now, plus v, 2x plus 3 to the 5th, times the derivative of u. All right. So now I need to take these two derivatives. So when I take this derivative, this is a general power rule. So this is a chain rule problem. All right, so I start with the power rule. I bring the power down, times the inside, power minus 1, so that's 4, times the derivative of the inside. So the derivative of 2x is 2, and the derivative of 3 is 0. All right, so what I really did was I went in here and I brought that out by taking its derivative. Okay, plus, it's because I'm not done yet, 2x plus 3 to the 5th times the derivative of x squared, which is 2x. All right, so now the rest of this, again, that's the end of the calculus. I'm done with the calculus. Everything else is algebra. Notice as we go through all these problems, and I've said this before, I'll keep saying it, the calculus is usually over in 1 to 2 steps, and you're done with the calculus. All right, most of this is algebra. So I need to clean this up, so I'm going to bring this over. So 2 times 5 is 10 times x squared times 2x plus 3 to the 4th plus, and then the only thing I'm going to do over here is bring the 2x in front. Just change the order that I'm writing it in. Okay. Now, because this is an applications class, as far as I'm concerned, if you get this far, you're good. You're done. With a lot of these problems, we're going to be doing things with them afterwards, so going any further with the algebra might not be necessary. But sometimes it is. All right, now, as we get to those points, I'll point them out. But especially if you want to check your answer in the back of the book, all right, you're going to need to take this all the way to the end. So that means factoring out any like terms. So I've got a 2 and a 10, so I can take out a 2. I've got an x and an x squared, so I can take out an x. And I've got a 2x plus 3 to the 4th and a 2x plus 3 to the 5th. So I can take out a 2x plus 3 to the 4th. All right, so what am I left with now? Well, 10x squared, 2x, so that's a 5x that I'm left with in there. I took out all 4 of those, so that's gone. I took out all of the 2x, and I took out 4 of those 5, so that's going to leave me with a 2x plus 3. So this is going to end up being 2x times 2x plus 3 to the 4th, 7x plus 3. All right, and this would be the final answer here. Okay. Oh, I know. We did a problem in class. Yesterday that I had to work out using the quotient rule. All right, and that problem was something along the lines of f of x equals 1 over, I don't know, x squared plus x plus 1. It was something like that. I don't remember exactly. And we had to do that with the quotient rule yesterday. All right, but now a lot of you recognized yesterday that I could take the denominator and bring it up, but when I did that, I ended up with something we couldn't deal with yesterday, which was this. All right, but now I have a rule that lets me do that. Okay, so take the derivative of f. All right, this is now a general power rule, so I can bring the power in front times what's inside to the power minus 1, which makes that minus 2, times the derivative of the inside. So the derivative of x squared is 2x. The derivative of x is 1, and the derivative of 1 is 0. So that would be like that. All right, so the last thing I want to do is to just clean this up. All right, so on top, I would have minus, I would have 2x plus 1, and on the bottom, I would have x squared plus x plus 1 squared. All right, and if you compare that to what we did yesterday, all right, you'll see that those are the same, or if it's the same problem, the same idea. All right, so you could have a fraction, and with the numerator being constant, if the numerator is constant, then you could just bring the denominator up and use the chain rule, right, as opposed to having to resort to the quotient rule. All right, so we've seen a couple of ways that we can combine rules or take something that looks like it's going to work with one rule and change it to work with another rule. How about this? We've got a few different ways that we could end up combining rules here. So if I do this one, f of x equals 2x plus 1 over 3x plus 2 to the power 3. All right, so if I want to take the derivative on this function, okay, again, I have to recognize what it is I have. And what it is I have here is a power function. So when I take the derivative, f prime of x, I'm going to take the derivative of this big power function here. So I start with the power rule. Power comes down times what's inside to the power minus 1, 2, times the derivative of what's inside. And if you'll notice, what's inside is a quotient. So to take this derivative inside, I have to use the quotient rule. All right, so remember the quotient rule, uv prime is going to be v times u prime minus u times v prime all over v squared. All right, so u is the top, v is the bottom. All right, so I have this, which is 2x plus 1 over 3x plus 2 squared times, now I'm going to follow the pattern for the quotient rule. So I do the bottom, 3x plus 2 times the derivative of the top. So the derivative of 2x plus 1, the derivative of 2x is 2, and the derivative of 1 is 0. Minus the top, 2x plus 1, times the derivative of the bottom. So the derivative of 3x is 3, and the derivative of 2 is 0. All over the bottom squared. All right, so I need to do a little bit of simplifying on the top here. So I'm just going to kind of scribble that in up here. So I'm going to multiply this out. So this is 6x plus 4. And then here I have to do a 3 and a minus sign. So that's going to be minus 3 times that. So that's minus 6x minus 3. And that's handy, right? Because now I have a plus 6x and I have a minus 6x. All right, so I'm going to do an extra step here. I'm going to write this one down again. And we're going to simplify this now. So when I put this together, I get 4 minus 3, so that's 1 over 3x plus 2 squared. All right, now the last thing I'm going to do with this one is I'm going to put it together. Okay, so I have, what do I have? I've got the same denominator here, so I can just kind of squish that together. So on top, I'll have a 3. I'll have 2x plus 1 squared. Now on the bottom here, I've got 3x plus 2 squared, and over here I've got 3x plus 2 squared, so that means I have 3x plus 2 to the 4th. And this would be the end of the problem. This would be the answer. All right, now there's a lot of different ways that these functions could be combined, okay? As many as you saw in the last section. And just to just real quick show you what the homework assignment looks like, okay? You can see the first few problems are all up through 14. These are all straight up general power rule problems. 15 through 20 are also general, straight up general power rule problems, but you have to do a little bit of algebra first to get them into the right form. That's a power rule. That's a power rule. Let's see, 23 is 2 power rules. 24 is the same. 25, 26. So it's not really until we get down here. Starting with 29, you're going to see they're going to start combining product rules and quotient rules in different forms, okay? So what you need to be able to recognize is, do you have, like with 37, Do you have a problem that starts out as a general power rule, and then when you take the derivative of the inside, you've got to do a quotient rule? Or do you have a problem like 41, where you're starting with a quotient rule, and inside the quotient rule, you're going to be doing the general power rules? All right, that will take practice. So I'm going to let you guys loose on these problems, and we will meet for real for a live class on Thursday.